Good morning, children. Today you are going to learn a new lesson, right? Okay, if I say like this is something that you're facing daily, but maybe you don't know the word that I'm going to use because this word is new to you. A little bit of big word. The word is, okay, no, I won't tell you the word. Now let's see. I'm going to show you something. What is this? This is a ball, right? Now see what I'm doing. I'm keeping the ball on this table, then I'm rolling it, right? I'm rolling it, so the ball keeps on rolling, right? I'm going to keep the ball again on the table, and I'm giving a push. What happened? The ball rolled a little bit, and then it stopped. Now see again. I'm giving a push like this. The ball stopped, right? Now, what do you think this push is? It's a force, right? What I'm giving is force. So, now, first what I did was, I kept on rolling the ball. I was giving the force again and again. So, kept on rolling. But then I gave a force, that means I gave a push, and then I stopped. What happened to the ball? The ball also stopped. Can anyone tell me why the ball stopped? Okay? Right. Yes. One reason is because I stopped giving the force, or I stopped giving the push. Right? Then there is another reason, children. Do you know the reason? Okay. That is because of friction. Why? Why did it stop? The other reason is friction. What is this friction? Have you heard about this before? I don't think so. Right. Now, let me explain you what friction is. Right? Now, friction is the opposite force given by the surface of this table. Now, what is the surface, children? Now, see, this is the surface of the table, right? What you can see, what you can touch is the surface of the table, right? This is the surface of this cloth, okay? This is the surface of the ball. Can you understand what the surface is? Right. Now, when you are rolling this ball, even though you can't see, there is an opposite force given by the surface of this table. And it helps the ball to stop from rolling. Right? Normally, if we take the meaning of friction, friction is the opposite force given by the opposite surface to stop or slow down the motion of something. Understood? Right. Now, children. Okay. Now, this is the surface of the table. Right? It's actually smooth. Okay, but if you take this, right, or this, right, it's not smooth, it's rough actually, right? So, on a rough surface, the friction is very high. On a smooth surface, the friction is very low, right? Okay, now tell me, if I take a bigger ball than this, right? If I take a heavier ball or a bigger ball than this, do you think that I will have to give a bigger effort to roll this? Or it's just the same effort that I have to use. Like, it's the same force that I have to use. Imagine that I'm taking a bigger ball than this, right? Do I need to give a bigger force for me to roll it? Yes, that's what you think. You think for a bigger object to move, we have to give a bigger force, right? That means you think if the object is heavy, it's really difficult to move. So now we are going to see whether this is true or not. Okay, right. Now I'm going to keep this aside and I'm going to take this saw. Right, here is a saw. I'm going to keep this on the table, then give it a push. What happened? It went forward, but very little, right? Now what I'm going to do is, I'm going to rub a little bit of water. Now let's see what's happening. What happened? It moved, but further, right? Okay. Now what I'm going to do is, I'm going to put water on the table to make the surface more smoother. When the soap was dry, both the surfaces were what? Rough, right? Not smooth, because this also was not smooth, this also was not that smooth. So it went little forward, then stopped. Then I put water on this. Then one surface was smooth, this surface was not that smooth. So it went further up and then stopped. Now what did I do? I put water here now, and you have water here also. Now see what is going to happen. It went further, right? First it went here, then it went here, now it went further up. So children, did I change the weight of this soap? No, it's the same soap, right? But what happened? Because of the condition of the surface, it changed how it moved, right? Okay, that means like you can clearly understand, not because of the size of the soap or the weight of the soap it moved, but because of the condition of the surface only it moved. When the surface is smooth, the friction is very low, or the opposite force given by the surface is very low. So it can travel further, right? So the misconception that you had, the misunderstanding that you had. What is this misunderstanding? A bigger object is difficult to move because it's heavy. That misconception is wrong according to this. Can you understand that, children? I didn't change the size of the soap. I just changed the condition of the surface. What I did was, little by little, I lower the friction of the surface, or the force given by the surface was lowered by me. That's what I did. So what you have to understand is, if the friction is high, or the force given by a surface, the opposite force given by the surface is high, there is a difficulty for an object to move. Is it clear, children? Okay, right. Then, now I am going to ask some questions from you. Alright?